Hi, this is Mr. Kutchell, and I got to tell you, about a week ago, a friend of mine suggested I go out and read this book about 2,000 birds. I went out and got this book by Harper Lee. I read the whole book. I couldn't find the 2,000 birds in it, but then I realized it was 2 kilo mockingbird. Well, I realized it was pretty dense at that point, and density is what we're going to try to talk about today. So let's go ahead and take a look at density. Density, by its definition, is mass divided by volume, and so this is the equation right here. This is always our original equation for density. We can rearrange this equation into multiple formats. So here's the original equation using symbols. D equals m divided by v. Here's another way of writing it. M equals d times v, and v equals m divided by d. So these are different forms. So when we have the mass can be any mass unit, grams, kilograms, and so on, and the volume can be any volume units, such as gallons, feet cubed, centimeters cubed, and so on. Usually we see it in grams per centimeter cubed. We can use this little triangle to help us to manipulate this equation. So for example, let's say we're trying to find mass. Rather than rearranging the equation algebraically, we just basically cover this up, pretend my pen is over the top of that, and then down what we have left over is d and v. So m equals d times v. That's what's shown in this equation here. Now up in this corner you see a picture of a man running around in the streets with just a bath towel on and a crown up here. That's because he had just figured out, this is Archimedes, and Archimedes had just figured out how to determine whether the king's crown was truly gold or not. He said, I will use density. He already knew the mass of the object, but he had no idea how to find the volume. If he knew the mass and the volume, he could divide them through, and if that was close to the density, if it was basically the density of what gold is, he would know that it was actually pure gold. How would you find the volume when you have an object like a crown that's not regularly shaped? Well, this is the way you do it. You would basically take a crown of some sort, you would put it into water, the water level would go up. As soon as that crown would be put in, the water level would go up to a higher level. This difference is called displacement. And knowing the displacement, Archimedes was able to figure out when he put the crown into some water, is able to figure out the amount of water that was displaced was equal to the volume of the crown. And he found out actually that the crown was not gold. Let's look at how density plays a role in everyday lives. Here we've got some regular Coke with lots of sugar in it. It's pretty dense compared to Diet Coke. A lot less sugar, it has carbonation in it just like this does, but because it doesn't have sugar in it, it floats. It's less dense than water, therefore Diet Coke floats and regular Coke sinks. Same thing happens with Diet Pepsi and regular Pepsi. Here's two masses of aluminum, exactly the same mass. This mass over here is 7 grams, and this mass over here is 7 grams. Now, it doesn't matter that these have the same mass. Notice their volumes are different, so their densities are different. This one here is solid, and its density is 2.70 grams for every centimeter cubed. cc means centimeters cubed. This one here has a larger volume, but the same mass. Therefore it has a density, and in fact its density is less than 1. I know that because if the density of an object is less than 1 gram per cubic centimeter, cc is a cubic centimeter, then it will float on the water. If it's more than 1, it will sink in the water. That's because water is exactly 1 gram per centimeter cubed. Here's some Ivory soap. This soap is floating. Is it more or less than 1 gram per cubic centimeter? Well, its density is less than 1 gram per cubic centimeter, and that's why Ivory soap floats. Other soaps are more dense than water, and therefore they sink. If you don't believe me, try it at home. This one's kind of cool. 2 bowling balls. Same size bowling ball, that's the key. Their volume is the same. But this one is about 12 or 13 pounds or more. So this one is maybe 15 pounds. This one here would have to be 11 pounds or less. So lbs is pounds. If you have a bowling ball that's less than 11 pounds, it will float in water. You can make a bet with your friends with this. You'll win it every time. Less than 11 pounds is going to float in water. That's because water, again, is 1 gram per cubic centimeter. This is a cubic centimeter. Centimeter by centimeter by centimeter. 1 gram per cubic centimeter is the density of water. This is something you need to know. 1 centimeter cubed of water is, by definition, 1 milliliter, and if you were to put this on a scale, would weigh 1 gram. That's where we get the density of water from. Anything greater than cubed, it would sink. Anything lighter than 1 gram per centimeter cubed, it would float. Submarines are that way. Submarines are very close to 1. And so here's how they work. They sink and they float because they can change their density. Let's take a look. Here's a submarine that we can see. It's got air tanks right up here. It's got air tanks here, and then it's got an opening along the outer hull. That outer hull can fill with water, and then the air tanks can open and blow that water out. So let's watch this process occur. It's going to submerge because water is filling up the outer hull. It's now greater than 1 and it's sinking. Now when those air tanks open up, it's compressed air, it will blow the water out and it will become less dense than water and it will surface. And that's what's happening there. And you could see from the picture we had right here, here's all that water being blown right out. That's water being blown out of a submarine as it's coming up the surface in a real quick way. That's an emergency happening right there. So they're blowing out that water very quickly. Here's another picture. Again, you can just see that's not just water just leaking off, it's being blown out. So they're trying to rise to the surface very quickly. Let's see how we can use these in problems. This says, what is the density equaling mass divided by volume of 25 grams when an object is 29.4 centimeters cubed? And if you were to go ahead and take this and put this into your calculator, you'd find out that this is going to be, I better double check, but I think it's 0.85. So we take 25 divided by 29.4, and we get 0.85 grams per centimeter cubed. Try it. Actually try it. Okay, let's do another one. Let's take a look at this one. This says the density of aluminum is 2.7 grams per centimeter cubed, and the mass is 202.5 grams, and what we're missing is the volume. So volume is what we're trying to find. Well, what we can do with this is we know that density is mass divided by volume. We multiply both sides by V. So volume times density equals mass. We still want to get volume by itself, so we divide both sides by D, and we get volume equals mass divided by density. This is called our working equation. So V equals M divided by, I'm sorry, let me start over again. V equals M divided by D, and we're going to get 202.5 grams divided by 2.7 grams per cent. And I apologize there, this is writing funny today. 202.5 grams divided by 2.7 grams per centimeter cubed. And what this will give us, if we divide this out, 202.5 divided by 2.7 will give us, I'll write it over here, 75 centimeters cubed. Okay, I'm going to go on to one more problem. I'm going to skip this one. Let's go to this problem here. If we have a dinosaur and it has a mass of 1.2 grams, so this little plastic dinosaur has a mass of 1.2 grams, what is its density? What is its density? Let's see if we can get this to work. Yep, that was a dinosaur, right? Okay, so the dinosaur has a mass of 1.2 grams. Ah, see what I just did there? I wrote D equals 1.2. That's not true. It has a mass, M equals 1.2 grams. But we're trying to find the density. Density is mass divided by volume. So if density is mass divided by volume, we got to figure out what the volume is. Well, going over here, we've got a volume of about 4.80 milliliters. And over here, we have a volume of 5.60 milliliters. So through water displacement, the difference in this water level, we found out that the volume is going to be 0.80 milliliters. So if we're going to try to find out the density, we already know that the mass is 1.2 grams. So we use the density formula. Density will be the mass by the volume. We substitute our numbers in. It's 1.2 grams divided by 80 milliliters. When we take and divide this out, we find that this little plastic dinosaur is 1.5 grams per milliliter, or a milliliter is the same as a centimeter cubed, so we go 1.5 grams per centimeter cubed. Well, there's dinosaurs around, and you know what that means. I gotta run. I gotta be safe. Take care. Thank you for listening.